Hello, my name is Dave Nielsen. I work at Redis Labs. I'd like to just start off by getting some things out of the way, such as I just started. So I'm still learning quite a bit. However, I have focused on this particular topic so I can give a good presentation around this topic. But if you're looking for advanced Redis conversation, I'm just not going to be able to do that today. However, maybe someday in the future. A couple other things is Redis Labs and Redis are not the same. Redis Labs is a company separate from the open source project. It does not own the open source project. So I just want to make sure that's very clear. And finally, this is just a talk about open source Redis, although I might mention our company and other companies once in a while, but it's not a pitch or promotion of Redis Labs. So we're going to talk, everything I say here is about open source Redis. I do have t-shirts, so if you stick around towards the end, I can give you a couple. Well, one each, but I've got one for all of you if you want one. Also, I took a lot of the content for this talk from a book called Redis in Action by Josiah Carlson. That's right. And I met him down in Los Angeles not too long ago. Super bright guy. If you ever want, the book is actually mostly free online at redislabs.com/academy, so you can go read it there. He's got a PhD. He's wickedly smart. Does not work for Redis Labs. Just happens to have partnered with us to promote this book. So let's go ahead and get started. Now, what I want to do is to give you an idea about what Redis is, and we'll give you some use cases. That's the primary focus of this talk. I don't know if I'll go the full time, but we'll see how long it goes. So first of all, what is Redis? Redis is an open source in-memory NoSQL database. It was created roughly around 2009 by a guy named Salvatore Sanfilippo. He's out of Sicily, Italy. And he's done amazing work, but he's not the only one. He's also got a crew of folks who work with him in the open source community. He did just recently join Redis Labs. So it's obviously a vote of confidence for us, but he's still working on open source Redis. So he's not actively working on our products or anything like that. Redis is known for being wickedly fast. It is a very, very fast in-memory database, and that's what most people think of it as, being very, very fast cache, and it's also a database. So it's both of those things. So what can you do with Redis? So again, like I said, a lot of people think of it as a cache. That means you might already have a database like MongoDB or SQL Server or MySQL or something like that. And there's certain parts of your website or your application that need to get at that data quicker than your database is able to respond. And so you might put some of that data in memory as a cache. So Redis is used primarily in that way. But it's not just a cache where you take and put strings. Oh, it's also a cache. That's kind of funny. Let me flip over here. Okay, it's also a cache where you can put data structures. So it has strings, lists, sets, sorted sets, and hashes, plus some additional data types like a bitmap and a HyperLogLog, which we will talk about a little bit further. It has 160 commands too. So sometimes you need to make a transaction or something. Well, there's a whole bunch of custom specialized commands that you can do with Redis, where it's created, these commands are created specifically to be high performant. So instead of writing your code that gets the data, brings it back, does something, and then sends the data back to Redis, you send the data in a function call, and it does all of the work on the server very, very fast. If you need to do something custom, where you want something to be done very, very fast on the server, you can use Lua scripts. Lua scripts are it's its own programming language, but it compiles into memory. So you're not leaving Redis to go do the work. It's actually all done in memory on the same server. And there's lots of different use cases. I'm going to go through some of these use cases, but you can store your sessions in Redis. You can keep a list of most recent visitors. You can compare which one of your friends are my friends. You can do pub/sub. There's lots and lots of examples. So who uses Redis? Tons of companies. All these companies that you know of, they all use Redis. it's incredibly fast. And if you have lots of people hitting your website, you can cache that data. But if you want to do something that's interactive or something where they're getting the most recent, let's say, posts to a website, like what Twitter does, that needs to be done more in a structured way. And Redis is perfect for that. So Instagram, Pinterest, Tumblr, Craigslist, Stack Overflow, GitHub, even Docker uses it to host all that data about their Docker images up on Docker Hub. I just heard a funny joke. The most difficult engineering job in the world is the engineers at Stack Overflow, because when Stack Overflow goes down, they can't use Stack Overflow to troubleshoot the problem. All right, who contributes to Redis? A whole bunch of people, but it's primarily Salvatore. However, there is a long tail of folks out there who contribute. You can see this is just a kind of a chart of contributions over time, so it's been fairly consistent and growing a little bit over time. But the product's very mature now, so they're adding functionality. But I think it's only if it feels like they're only adding things that are going to help make it faster, or some edge cases, but the primary functionality seems to be there. So where can you get Redis? So you can go get it from the open source download off of GitHub. There's also redis.io. It's a great resource for Redis if you're looking to get started. There's a lot of material there, documentation at redis.io. If you want enterprise cluster, Redis Labs, the company I work for, offers that. You can get a free download. You can also use Redis Cloud, also by our company. This is Redis as a service up on Amazon, on Azure, on Google, on IBM's clouds. So we run it in all of those clouds. And there's lots of other companies out there. So you can go to Redis Green, Open Redis, again, Redis Cloud, and Redis to Go. These are all different Redis as a service providers. Even Amazon Elastic Cache is based on Redis. So, and Azure's cache is also based on Redis. So Redis is very, very popular. So again, let's go into some details here. So, what is Redis? So very specifically, some people, you've probably heard the term, key value store. So Redis isn't really a traditional key value where the value is a string. It's what we call a key data structures server or store. And what that means is it has more than just string values that get stored in cache. You can store data that's more like a database. And there's different types of data values. So you can have strings, lists, sets, sorted sets, and hashes. A hash is kind of like a hash table. So that's very similar to a table. You can also have BitMaps in memory. And there's something called a HyperLogLog, which I'll talk about briefly. It's kind of a new thing. It runs in memory, as I said before, which means it's extremely fast, both for reads and writes. And it does have disk persistence, so you can have a log and you can capture the data so that you're storing it on disk, and therefore if something were to happen, it goes down, you can survive the crash. It'll load back up for you. And because it only runs in memory, your limitation primarily is the memory available on that particular server. You can cluster Redis. You can do it with the open source version. However, if you need help or if you feel like you just rather have somebody provide you the technology that does all that, that's what our company does. But let's move on to how Redis is used. So it's, like I said, it's extremely easy to use. It's very well documented up on redis.io. So, go take a look. There's lots of good, useful information there. Most people use it as a cache or as a second database. So if you've got a database on your server that's saving your data on disk, but you are having problems scaling that, you can use Redis not only to cache, but also to keep the data from the database in memory so you can query it. And some folks actually do use it as a first-class database. In other words, they don't have another database. This is their only database. Usually you might do that if the data that you're keeping in your database isn't very useful after a short period of time. Like, for example, in high-frequency trading or something like that, where all the data is really happening in real time, and maybe you stream it off and store it somewhere as a log, but you don't really need to keep that data. If it were to go down, it wouldn't be useful to bring it back up because time has already passed. So who is using Redis? There's a lot of different companies I mentioned before. You can go take a look at this URL and see tons of companies using it. And by the way, I forgot to mention, it's also great for other things like PubSub. A lot of folks use it for PubSub. So what that means is you have a lot of web browsers open, and they're all viewing a shared set of data. Then you can have them subscribe to Redis, which will then let them know when a change occurs, and they can all update their browsers simultaneously. I've actually written an application using Node.js for that. And there's a configuration file that you set up. It's really simple, so it's actually quite simple to set up individually. It's also single-threaded. This is kind of interesting. So what that means is it's only doing one action at a time. So it queues them all up, and it does them all in a row. This actually helps with performance because you don't have to worry about a record being locked. It's just doing one action after another. There is no locking because of that. So, and it's so lightning fast that it actually is quite hard to give it so many requests that it can't handle the load, although you can, and that can happen. So it's incredibly fast, and the single-threaded actually helps with that. What this means, though, is you tend to shard. If you run out of memory, you need more space, you tend to shard your database. So you might have transactions A through F on this database, or on this server, G through, I don't know, M on this server, and N through Z on another server. So that might be typically how you were to scale. And OK, so I mentioned earlier, or maybe I didn't, but anyway, it's often compared to Memcached. Redis actually supports Memcached for the most part. So a lot of folks actually have used Memcached, might switch over to Redis because they get the Memcached functionality plus the Redis functionality, and it's just as fast as Memcached in most cases. And again, you get this rich set of data, not just key value pairs. You get to store data in a structure, so you can do querying in memory. And it does support persistence. So if your server goes down, you don't have to. Your server might have to come back up, or you can recover from another server. But you can recover all the memory at once. You don't have to wait for it to rebuild, which can be very slow and painful. And it does replication through a master-slave concept. So you can have a set of your data in memory on one server. It can keep a copy in another server. That means if your primary server were to go down, it can immediately switch over to use the copy, and then therefore you don't have any downtime. And in a very common scenario, you would actually have a master-slave scenario where the master is doing all the interacting with your applications, and the slave is actually doing the saving to disk. So they both have their role, and you can perform better that way. So what are some more use cases? Oops, somehow we lost. There we go. OK, that's funny. So what are some use cases? One example is you might show the last items listed on a website, on your web page. eBay postings or listings, something like that. Obviously, at some point, you need to remove them, so you'd have deleting or filtering based on certain criteria. You can do that too. That would be hard to do in a cache where there's no idea of individual records that are in a set. A leaderboard actually makes a lot of sense with Redis. So you might have a bunch of users all competing, and then based on criteria, you could very quickly and easily filter that data and show the top players of all time, top players this month, top players today, top players right now. All of that could be in memory and sorted quickly and displayed in real time. Also, user voting. You can use a sorted set, which I'll talk about in a little bit, where you can let people vote. And then you've got your names of people or ideas or products or whatever you're voting on, and then your votes. That can all be kept in memory in real time. And you can expire items. So, for example, this is great for things where you know that you don't want that information to display after a certain period of time. You can set an expiration date on the record, and then it will automatically, you don't have to go back and remove it. It will automatically remove itself from the list, and therefore automatically stop displaying on the web page at that time. So a lot of very useful functions. Now, I've got more for you. Counting stuff, that's probably pretty easy to do. Unique items. So they've got some functionality where you can say, add this to the list, but only if it doesn't exist on the list already. And you don't have to worry about writing that functionality. Redis just does that for you. So that way you can keep it unique without any effort. You can do real-time analysis for what's going on. So if you want to add any information like maybe you're keeping track of bugs from an API. So as an API comes in, every time there's a error message or actually all responses, you can just log them all in memory, and then in real time you're keeping track of all of that activity, and it's all quickly available from your dashboard to see what are the top error messages, that kind of thing. Like I said, you could use it for pub sub. It's also great for queues. There's functionality where you can pass in you can make a request using a function that says remove an item from this queue and put it into this queue, and it will do them effectively in a transaction, because again, it's all serial, so it'll do that all in one action, and therefore you know that information will get moved from one queue to the other without losing data. So a lot of high performance operations like that. And like I said before, caching. Caching is like extremely popular with Redis. And but I don't want you to think of it as just a cache, but it is a very, very good cache. So the key takeaway from looking at these particular use cases is that with high-speed data where you're trying to keep your website responding to really unusual usage patterns that your database wasn't really designed for, rather than trying to model something very cleverly so that you can take your model and mirror it on the website and keep updating your model to match the performance required, the best probable scenario is just simply take the data, keep it the way it's stored, the way you need it to be stored in your own system, but then remodel it using something like Redis and just put it in a way that it's going to perform better for your website. And you can take each individual use case and customize it for that particular scenario so that it performs quickly. And don't worry about changing your own model. You can combine these functions together to get what you need. And because it does the work for you, you don't have to write your own code, which is most likely not going to be as fast. So instead, you can call the function, have all the work done on the server, and then you're done, rather than getting the data, pulling it back, doing the work that you need to be done, and then resubmitting it to the database. That's not likely to be as fast. So there's a bunch of data types. I don't have any much more than this, so I'm going to go through some data types for you, and then we'll be done. So let's just take a quick look. You got your string. Okay, it's more or less what you think it might be. You can store a lot, up to 512 megabytes in one string. And it's ideal for all sorts of things. You can do JSON. You can store your data as JSON in a string, just like you would MongoDB or something like that. You can store little bits of data for real-time metrics, or like I said, like active users. You might just store that in a string and just keep that in string instead of a table. You can store binary files, so if you're actually serving images, you can keep that in memory as well. Here's some examples of some functions, and the use cases, you can do a lot of stuff with this. For example, you can actually tell a record that you want it to not change, like set that value, and it can't change, nothing can change it, and then after a period of time, it will either automatically delete or then become changeable. Again, you can use it for a cache. You can put up images, and then you can have you can actually write over the image. Put words or something like that over that image, and let users download that data without having to save it down to disk. So that can be very quick. You can use it for just simple things like A/B testing, and so that it's not you're not having to save a bunch of data. You just kind of look at who's coming in, figure out, oh, it's this session. We'll do this test. So keep some flags in memory, that kind of thing. Lots of different use cases where you just don't need to go put all this in your database. Lists. So these are just internally maintained as linked lists. They're extremely fast, especially towards the beginning and the end of the list. So you can have very long lists. And you can use this again for like queues or just stacks of data, top end, recent news, that kind of thing. This is what a lot of folks use for social networks. So this is what Twitter uses. Pretty much all those social websites are using this functionality. And useful for logging users' actions. This rpop push is what I talked about earlier, where you can kind of take an item out of a queue and stick it in another queue all in one function. We also have sets. Sets is just simply a unique list. So you throw some data in there. If it's already in there, it just ignores it. It doesn't add it again. Or you can use sets to compare one set with another set. So your friends with my friends, we can very quickly figure out which friends we have in common. You can find out, hey, does this number already exist? That kind of thing. Lots of very simple but very highly effective and fast functionality. Again, it's great for storing social data. Here's some functions. Oops, that kind of got whacked out. So you've got some tracking IP, unique IPs to your website. So if, for example, if you're trying to defend against a DDoS or something like that, you could use this functionality to say, hey, you know what, I've gotten too many requests from this website in this short period of time. You can set the automatically expire so that you can set it off at 10 seconds or something like that. And if a person keeps coming back more than 2 or 3 times per 10 seconds, you might decide that that's something unusual. Used tagging information, creating random numbers so you can respond for ads or lottery information, tips of the day, that kind of stuff. That's all great for in-memory. Sorry, that page was a little off. You can, a sorted set. A sorted set's kind of interesting because you can add a value to the number or a value to the data. So this is how you would keep track of, like if people are voting and you have a value next to the list of data, and therefore you can have a sorted list essentially, or a sorted set. And basically this behaves just like sets, except for you have that value next to it. And it's still extremely fast. And the queries are very fast because the sorting happens immediately upon insert. So the queries are always going against static data. It's very fast. And again, for using examples like a leaderboard, top lists of anything, you can index other data. So if you have hash tables or other lists, you can index them using a sorted set that references off to another structured type. You can, like for example, querying for a range of users, all given a date or age or some other characteristic. And finally, of the 5 main types, you got the hash. And hash is kind of like a table, very similar to a table. And so you've got the value, like a unique user ID, and then you got all the additional values that are stored along with it. You can kind of nest one hash within another, but then that's about as far as you can go. And you can refer to each one of the values individually, and you can even sort them. So it can behave more or less like a regular table. This is where you would store data if you're storing data for example, in a business object. For example, like maybe a person and their characteristics, or an automobile and its characteristics. You can store all that in a hash, and you can keep track of many to many mappings that way. And there's a couple bonus types. There's BitMaps and HyperLogLog. So as I mentioned earlier, you can store images in memory and then manipulate them in memory, and there are operations specifically for that, like BitOp, where you can take a particular range of pixels within a range and update them or edit them. And then, like I said before, you could use this for putting text over an image, all doing that in memory, and then not having to save that to disk because you may not need to do that. It might just be on the fly. And then the HyperLogLog is kind of interesting. It is what they call a probabilistic cardinality estimator. It's a mouthful. What that really means is you can count a value within a larger string or sets of strings statistically. So you've got, perhaps millions of web pages all with data on it, and you want to know how many times does a particular word show up in those millions of web pages. Well, rather than keeping all of that data in memory, what happens is you can iterate through all the data, and then the HyperLogLog will estimate, will keep a track of an estimate of how many times the words show up, so that you're not having to keep everything in memory in order to find that out. This would be very useful, for example, when you do a search on Google and you were to do a search for Redis, it would tell you how many times Redis shows up on web pages. It's not actually doing an accurate count of that in real time. It's getting an estimate. So it's similar to that. So I'm going to start wrapping things up here. I've got this, like I said, there's a lot of information that I got is from the book Redis in Action. You can go check it out at redislabs.com/ I kind of spelled that wrong, but Academy. And then also a couple other things just to mention. I'll be back up here in just a few weeks for something called ContainerDay, which is actually happening at night in Seattle. So if you're interested, I can also get you 30% off the LinuxCon conference that's going on. So if you're into Linux or anything like that, you can go to the conference for 30% off. But the event I'm putting on is free, and you can go check it out. It's August 16th, downtown Seattle. You can find out more at the Twitter handle ContainerDay. And that's about it. So I can take questions. I also have some shirts, and I think that's about it. So yeah, that's it. So if you have any questions, like I said, I'm fairly new, but I can get some answers if I don't know the answers. So why don't we start with you in the back?
So can you do cross data center replication?
Yes, you can. Now, like for example, on Amazon or Azure, where you have availability zones, those are probably close enough where something where the time to replicate is reasonable. But like cross-continent or around the world, replication would be potentially problematic depending on how fast you're updating the data. But yes, you can do that.
So, but the RLTC is a product? Is there an open source cluster?
Yeah, actually there is an open source version. It's fairly new, but if you go to download Redis 3.0, whatever the most recent 3-point version is, it does have clustering in there. So you can try that, and it's the open source version. And then and then Redis Labs provides a supported version that's more based on proprietary clustering that we've created. It is not the same as the open source version.
One more question.
Yeah.
Does either the clustering work for multi-core? Because like you said, it's single thread, right? If it's on a multi-core, then it's really pretty much wasting all of it.
Yeah, typically what will happen, and again, typically what will happen is you would set up Redis so that you're installing multiple Redis databases, one per core, and then you would basically chart across that. That's how you would handle that. Okay.
Can Redis be used as a write-through cache for Azure tables? I believe Redis is available from Azure subscription model, some sort of like that. So I was wondering if that's supported.
So that's a good question that I haven't looked at myself, so I don't know. I do know that somebody said that it would be a good topic for a webinar or a talk to talk about how to do that with Redis. So I'm pretty sure, based on the fact that he was proposing it, that you can do it. I'm not exactly sure the best way to do that. There's a hand back up here. Yeah.
You mentioned
Okay, so is there any concern of network blocking? I didn't hear the second part of that.
Since Redis use single thread, and we support have some model where I assume it invoke network I/O. Would the network I/O be blocking?
Yeah, you mean, okay, so let me try to understand your question. So would the network actually end up becoming the blocking element of the query? Yeah, so this is not an area of my strength, but Redis does support pipelining of network calls to the Redis server. So what that means is in the client that you use, if you want to use a client to talk to Redis, the server, it can actually queue up the requests and then send them to the server to get the data back. And it does it in a way that actually speeds up the overall transactions or the operations. I honestly don't know a whole lot. I know what's going on there. Basically, what's happening is you've got so many requests coming in. The database may actually be fast enough to handle those requests, but the network may not be able to handle those requests. So in that particular case, you can help the network out by saying, well, rather than sending one over at a time, let's queue them up and we'll send over 10 at a time, for example. And then Redis is so fast that it can easily handle the 10 and respond and faster than it would have taken to send over 10 over individually. So that's how Redis would handle that. And I believe it actually does a good job of solving that problem. Yes?
So for the cloud-based offerings, you mentioned that there is one shard per core.
Yes.
So who does the management of the shards? How is the sharding done in a cloud offering?
So I actually don't know very much about how the open source Redis does that because it's fairly new and I haven't studied that part of it yet. So I can only tell you how Redis Labs would do that. I'll keep it short. Essentially what happens is Redis Labs would do two things. Number one, it would use up all of the memory for that physical server, except if it determines that it would have better performance by using multiple cores on that physical server, then it would do that. It would split up the memory to multiple cores based on performance. And then it would essentially automatically shard for you, okay? So it would automatically figure that out. You don't have to figure that out, like which data to put on which server. Does that answer your question? Okay. Yeah. All right. I can't. Oh, yeah, it's in the back there.
For scenarios where the memory in one box will not suffice your needs, and you have to go to a remote box, how do you guarantee performance? Do you remote? You do RDMA or mandated independent? How does it work?
So the best way I can answer that question is that you can install a client on each one of your servers, your application servers, that can maintain a hash of where the data is actually stored so that the requests are not going through a proxy and then to the node that has the data on it. Instead, the web application can connect directly to the node that has the data on it, and therefore there's a no shared anything, a shared nothing architecture, and therefore it should scale fairly linear. Does that make any sense?
Yeah, but aren't you still bottlenecked by the size of the pipe for the network? You do something.
I don't have a good answer for that. I don't. Again, like network operations is not my specialty, but yeah, at some point the network can become a problem, and I know that there are optimizations that have been made to handle that, like I said before with the pipelining, but I don't know anything more than that, honestly. I can tell you that in some cases, for example, storing session data, it actually makes a lot of sense to store the data on a separate server and not have it be stored on the web servers themselves, because otherwise you're having to do all that network traffic just to keep an updated cache on all of those servers. So keeping it stored on a separate server actually makes a lot of sense. All of your web servers can talk to the same cache for session data. But there may be certain circumstances, perhaps if you're doing some ad serving or high performance trading or something like that, where you want to have your cache on all of the servers, and that's probably going to be a custom setup that you would do yourself. Okay, so I can't really see back there, but I don't see any more hands, so I think we'll just call it a day. And like I said before, well, by the way, thank you for your questions. If I didn't answer any of your questions fully, I'd be happy to go and get more details for you. I do have shirts, so if you would like a t-shirt, come on down. I'd be happy to give you one. Other than that, thank you very much.